Well, we learned from Matt that the acceleration of gravity is 9.8 meters per second squared.
What? Hello? I'm sure that means something very impressive.
It does.
My degrees in journalism, you can tell.
He'll explain all about it.
Well, I don't know much about that, but we know someone who does. We're headed back to the lab with Matt Sellen for some explanation. Good morning, Matt.
Okay, so we're back to talk about gravity a little bit more. And so far, we've shown you what Galileo has been, or discovered over 400 years ago. And we saw that, first of all, that everything falls at the same rate due to the gravity. And it took people a while to figure this out because you're easily fooled by air resistance. And so it was kind of a real intellectual leap for him to figure out that, to imagine what would happen if there was no air, because of course they had no vacuum pumps. But the other thing that Galileo figured out was that when something falls with a constant acceleration, it speeds up uniformly, and the distance that it covers every time interval increases very rapidly. It increases like the square of the time. So if you look at this thing, what I have here is I have a string with some red washers tied onto it. Between the first two washers is, let's say, 1. It's between the first one and the second one is 4. The first one and the next one is 9. And we're going to use this to illustrate that when something falls, the distance that it travels is proportional to the square of the time. And so this is one experiment we're going to do. I'm going to release this thing. Plate. So on the count of 3, I'm going to release it. You should hear this. 1, 2, 3. Click, 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 click. Even though the things were very spacings between them, they hit at even time intervals. So what I have here now is this contraption we built out of a ramp and some truck lights. These lights are blinking about every second. The spacing between the lights, though, is just as uneven as those were up here. We have 1 unit, we have 4 units, which is 2 squared. We have 9 units, which is 3 squared. And so each second, the thing increases its distance from the beginning point by the time squared. So if we wait twice as long, it's gone 4 times as far. So I'm going to release this thing, and you're going to see that this ball rolls in such a way that it's at the light every time the light blinks. Okay, so I'm going to go right now. And this was actually an experiment that Galileo did. Of course, he didn't have electric lights, but he had little bells that the ball hit as it went down. And what he actually discovered was that the distance that the thing goes increases by a factor of 4 when you double the time. So in other words, the distance goes like the square of the time. And he used a ramp like this because you can use a ramp to dilute the effects of gravity, and so that you don't have to watch the thing fall so rapidly. It rolls kind of slowly. So anyways, for next week, please answer the following questions. Gravity is one of the forces. What are the other fundamental forces that we have? List them all, send me an email, and you can win a t-shirt.
That's a tough one. All right, Matt, thanks for being here this morning. It's tough.
Yeah, that's interesting. I always found it amazing that time is a unit of measurement, and if you actually think about that, it's pretty amazing because you can use that to measure things, which again, if you just think about it for a while, it's kind of a neat thing.
It's amazing.
Yeah.
Physics at work.